We don't really do 2.6. It covers some stuff that we don't need yet in terms of our curriculum. But 2.7 is about proportions. It is a big section, so make sure that you take your time on it and that you work hard on it. But again, it's just your third one. I believe that this is the last section of the week, looking at your work there. So what is a proportion? In order to answer that question, we must first answer the following question in terms of what is a ratio. A ratio is a fractional representation of two numbers that are related. So 4/5 is a ratio, 11/17 is a ratio, 7/3 is a ratio. And they are fractions, but once you connect those numbers in some real life way, it becomes a ratio. For example, it took 4 hours to paint 5 fences. That could be represented as 4 hours to paint 5 fences. That is a ratio now. Joseph was able to ride his bicycle 11 miles in 17 minutes. 11 miles in 17 minutes. So you can make a ratio out of that. Jasmine can feed 7 guests with 3 cans of spaghetti sauce. 7 guests with 3 cans of spaghetti sauce. Again, you can make that into a ratio. So it's a fraction, but it's a fraction that has an actual connection in a problem. Once you understand the idea of what a ratio represents, you can look at the definition of a proportion. A proportion is a result of setting two ratios equal to each other. And pretty much what you do is you're using that one situation to kind of compare it to something else, and that's how you know you're going to have a proportion problem. Any math problem in which one fraction is set equal to another fraction, you will use the skill of expanding proportions, which is what you're going to need to make sure you copy when we do those. How is solving proportions different than solving equations? Once you know how to expand, pretty much there's no difference at all. Remember, I just told you that all that's going to happen the rest of this chapter is we're going to give you different versions of things to solve. It's going to take you further from base. You just do a couple steps and you'll be right back where you were in our last lessons and in our last week. In terms of strategy, the expanding of the proportion is just a step that leads to a pretty basic solving problem. So the expansion is not really solving. It's just something that sets it up so that we can actually find the answer the way that we want to. So not going to solve these yet, but again, copy these down for yourself. Expand the following proportions. What you do to expand a proportion is you cross multiply. So you pretty much take this term times that term and set it equal to this term times that term. That's it. Hopefully you understand. That would be 11x, that would be 12, and you would answer from there. That is what you do when you see a proportion, is you expand it out and then you go ahead and solve it. So again, if you were asked to expand this one, you would take x plus 5 and meet it up with 6 through multiplication and set it equal to 2, meeting 9 through multiplication. Again, hopefully you understand that would be 6x plus 30, that would be 18, and you would solve as usual. Even if it looks ugly, you simply follow your steps. X plus 6 meets 3, and 7 meets x minus 2. As long as you follow what I'm asking you to do and expand it out, it should not be a problem for you. The issue that I have is students who, kind of say, I don't like writing all that stuff and your way is stupid and I'm going to do it my way, and then they end up making a mistake and they get frustrated because the reason why I teach the way I do is to minimize your mistakes. Just be sure not to confuse an equation containing fractions with a proportion. This is not a proportion because of this part here. It has to be a fraction equals a fraction. It can't be fraction equals fraction and number, but it has to be actual 2 over something equals x over something, or like this one where that is a fraction with everything over 7. That is a fraction with everything over 3. Just make sure you're aware of that and we'll be good. In terms of application problems, be sure to link the units. That is how you do that part where I said it took 4 days to do 4 hours for 7 fences. Pay attention to your units. So if you had a problem that said Joe earned $17 in the first 3 hours of work, how long will it take to earn 50? This is where you're trying to take a situation and expand it to see for a different situation. So what I would do is make a ratio with 17 and 3. Then I would put a equal sign and set up a fraction. Here's the thing. Pay attention to the unit. 50 is in dollars. The other number in dollars is 17, which means 50 should go with the 17. And so we would put a x underneath because that's what we're looking for. Obviously, what we just talked about, you would do 17 times x equals 3 times 50. Solve that and find your answer. Again, I'm not going to work that out yet, but that would be what you would do. Those 3 dots typically means go ahead and follow what you've learned to do it. Now we're going to the examples where you'll actually copy it, because we do have word problems in that too. So in this problem we will do 15 meets 7 and x meets 8. 15 times 7 is 70 plus 35, which I believe is 105, equals 8x. You are going to see fractions in here. We're going to divide by 8 to get rid of that 8. I don't think 105 can be divided by 8, and so your answer is just 105 over 8. Now the rule with your work is that you do need to make sure you reduce your or simplify your fractions, but I don't think 105 over 8 goes any further than that. But that's it. 26 over 29 equals 13 over x. Again, what we're going to do is 26 meets x equals 29 meets 13. Keep the discipline and it will be very easy to do. This is 26x. 29 times 13, I don't think I know in my head. I should though. I know I should. Actually 290 plus, what, 57, which would be 347, I guess. I don't know. 347, let's see if I'm right. 377. And then in the end you divide by 26. Divide by 26. Again, I don't think that 377 over 26 is going to divide, but I think that I can reduce it. I don't like this calculator for that reason. 29 over 2 is what that would be. I guess you can divide both of them by 13. But yes, that's all you have to do, is make sure you expand it, solve it, and then reduce your fraction if you have a fraction left over. Some of the ugly ones, which really aren't that bad. X minus 2, again, as long as you follow your fundamentals that I'm trying to teach you here. 8 meets 3. Distributive property means 6 meets x, and 6 meets 2. 8 times 3 is 24. From what we've learned, we move the 12 by adding it. That'll be 36. And then you move your 6 by dividing it. And that gives us our final answer. So again, not bad, just something that you've got to make sure you know how to do that part. This is the only new information in your solving, because once you have it expanded, you do what you've been taught to do, and you get your answer. Here we put x minus 1 meets 9 equals 6 meets x plus 1. 9 meets both of these things, making 9x minus 9. 6 meets both of these things, making 6x plus 6. I think we just learned yesterday, maybe, I don't know. I forget what we did when we did that lesson, but I know we learned that we have to declare a side. I think it was section 2.4. And so we'll move the smaller variable over. By subtracting it, we get 3x minus 9 equals 6. Now we're right back where we were before, where we have to move the weaker number, which is the 9. And then we divide by 3, getting our answer of 5. The real word problems that you'll have, this is a question you'll see on your homework, so make sure you actually copy it and understand where it came from, because it is going to make you do a proportion and everything on the computer, so be ready for that. It says an airplane travels 680 miles in the first 4 hours of a 950-mile trip. Write and solve a proportion to find the total amount of time t needed to complete the trip. Pretty much you have to do that and solve it, but here's all you have to do. Again, they give you a situation, 680 miles in the first 4 hours, and they want you to expand it to a 950-mile trip. So I would put 680 over 4, because those two are related. That is a ratio. And then I would set up my equal sign and draw my line for my fraction. Looking at the third number, it's 950 miles. The number of miles is also 680. That means 950 should go with 680. And it says t here, so I need to put t there. That would be what you have to put in one of your boxes. Make sure you understand how to do that. But then they want to know, because they actually are going to want to know. So we'll do 680 times t equals 4 times 950. Let's see, 95 times 4 is almost 100 times 4, which would be 400. But it's 5 short 4 times, which is 20 short, so is it 380 with another 0. I don't know. Yep. Anyway, divide those two by the 680 to solve your answer. And you are going to do this in decimal. Make sure you round to the nearest tenth and understand that this 8 is going to bump that 5 up to a 6. If you do not round it correctly, it is going to mark you wrong. So 5.58, which does equal 5.6. Alright, because again the 8 bumps the 5 up. If it was 5.50, I would have put 5.5, but again, just be ready for that when you see it, and feel free to email me if there are issues. A chef is preparing for a banquet. If one cake can feed 17 guests, how many cakes will the chef need to feed 280 guests? Again, you have a situation here where you have a situation, it tells you a general situation and wants you to expand it for a higher situation. So one cake, notice the one was hidden, can feed 17 guests. Again, it wants to expand to 280 guests. Well, guests here is the same as 17, which means 280 should be in the same location as the 17. I'm going to put C for cake. And again, just do what we've been trained to do. 1 meets 280. 17 meets C, which means 280 equals 17C. Divide by 17. Again, the solving we've been working on. You get 16.47. And I did this for a reason. Because some of you, if you were given a word problem or the SAT problem or some sort of problem here, you would say 16 cakes because 16.4 it rounds to 16. But would 16 cakes actually feed 280 guests? The answer to that is no. So even though it would round to 16, once you get past 16.0, you actually need 17 cakes to get that done. It wouldn't matter if it was 16.001 cakes. Once you pass 16, you have to make another cake. Otherwise, people will be hungry and not liking the fact that they're not getting cake. Remember, the only new step is pretty much expanding. Be sure to use the formal steps when the proportions are challenging. That way you don't make a silly mistake. Again, when things get tough, slow down and use your fundamentals. That is the key. Here are your notes that you're going to copy. After you copy those down, please make sure you answer that question for credit. Good luck.